Hello there, Math 124 fans. Going to continue now into part 2 of this Math 124 Exam 2 prep. So, leading one of the topics that comes up as you're studying derivatives is parametric equations. Parametric equations play a major role once you get to 3D calculus. This is the beginnings of that discussion. Excuse me. But for those of you that have taken some physics or some sort of applied problems, almost always when you're doing studying motion, it's parametric. For example, if I take a ball and throw it, I've just made up an example here. We typically think in terms of, okay, it has some initial speed or initial velocity, and you have a x component of velocity and y component of velocity. Just the idea of parametric equations bothers people because you often haven't had to use it very much by the time you enter these courses, but the more you stick around, the more and more you're going to use these things. So I just made up a random example. So the way you use parametric equations is we think of t as if it's time. And so that bothers people a little bit, that typically you don't plot t directly. You just use it as a go-between. So when this is 0, you get 0, 0, and there's our starting place. T equals 0. 1 second in, we've gone 5 units to the right. In fact, that 5 is going to play an important role in discussing this, and we've gone 4 units up. Okay, so maybe we are, I didn't think about where the vertex was. Well, this is bad for me to make up a question on the fly, but we've gone over 5, up 4. And you can keep plotting points to describe this motion. So since our goal in Math 124 is to be able to take the derivative of anything, we need to be able to take the derivative of such situations. And it turns out the chain rule gives us a way to do this. dy dx is dy dt over dx dt. So basically what we call that top thing is the vertical velocity. So if we take the derivative of just the y, you get negative 32t plus 20. If you take the derivative of x, that's called the horizontal velocity. So in this case, every second, you're going 5 units this way. Then the next second, you're going to go 5 more units. And the next second, you're going to go 5 more units. That's how it works because gravity is just working up and down. So when you throw something, if you don't include air resistance, it would just keep going in that direction until it runs into something. Anyways, that's the slope. Now it gives you an answer that's in terms of t. So often the challenge is, if I give you some point along the way, an x and y, for example, like if I told you x was 5, you first would have to solve and figure out that t is 1, and then you could plug it in and find the slope. If I clean that up, and in this case it's kind of nice to clean up because it's not too bad. This is 4. You can find the second derivative. Now, this is not a major topic in the homework. I think you have a couple problems, but I just wanted to make a comment. It's as if you have just a whole new function. What I mean by that is, it's kind of like what we just did, this ratio, except on top, instead of it being y, it's the first derivative. So we take this and think about it like, what if that was y? And then we want to take the derivative with respect to x. It looks a little funny, but basically you take the derivative of whatever you just got with respect to t, and you divide by dx dt. So the weirdest thing is you're going to divide by 5 yet again. But it's because you're measuring the rate with respect to x, and every time time goes up, x goes over 5. That's what's happening. The truth is, I haven't encountered that many situations where I'm computing the second derivative with respect to x. We're usually computing something else in application, but anyways, this is what you get. Okay. The only other thing we sometimes measure, and this is more for Math 126, is what we call the speed. And the speed of the object is the square root of the derivative of x squared plus the derivative of y squared. So in this case, it would be 5, and it would be this. So the speed is the square root of x prime. So all of those things, I think, appear in small doses in the homework. The main thing that appears is the derivative. So I just wanted to do a quick recap of the things you've seen. Okay. So let's get rid of those things. And then let's look at a few old exam questions. And I hope this is of help. If it is, please let me know. It's helpful in the comments. Okay, so this is a random old exam question from one of my exams. Here I give a much messier parametric equation. Lots of stuff in there, looks scary. Find the formula for the vertical velocity in terms of t. Okay, so that's asking for dy dt. And what do we get? So it's really just a derivative question. We have 4 terms. The sums and differences come along for the ride. The derivative of 5 is just 0. The derivative of log of 4 times t is, the log of 4 is just a coefficient, and the derivative of t is 1. This one actually is going to require some work because it's got something trapped inside. So 3t plus 1 times the derivative of the inside, which is 3, and I think I'm just going to write that there. And then lastly, this is one of our sort of lesser used rules, but it's this. It would be in your table of things you know. Okay, not too much to say there. Find the speed of the particle at time 0. So this means x prime squared plus y prime squared. In particular, it's asking at time 0, so that's even nicer. So you can really just plug in a 0 to what we just got, and that will give you y prime at 0. So y prime at 0 is going to be 3 plus log of 4 minus log of 4. Ah, I made it nice. So this is just 3. X prime we haven't computed yet, so let's do it now. X prime is t squared minus 7t plus 10, and we're plugging in 0, so it's just 10. So it's the square root of 109. Okay, feet per second. Because all the units were in feet and the time was in seconds. Let's keep going. Find the equation of the tangent line to the curve. Okay, so the moment it says that, you're trying to give the equation for a line. Now, in general, the equation for the line, especially when you're doing calculus, is usually easiest to write in this form. If you want mx plus b, you can just expand. But you're looking for x, y, and slope. Since we're talking about the tangent line, the slope is going to be the derivative. That's dy dx. That's where we're going to have to use our skill. The x value and the y value we're also going to have to compute because they didn't give us either one. What they gave us was t. They told us t was 0. So we would like to know all 3 of these things at 0, and when we have them, we will be done because we can plug them in. M will go here, x will go here, y will go there. Okay, so if you didn't remember how lines work, I do have a practice page on my materials page that just has to do with parametric and tangent lines. So if you'd like to see several problems with a bunch of visuals, I got it. All right. So anyways, what do we got here? So if I plug in 0 to the original things, I get a 2 for x, and I get, okay, log of 1 is 0. E to the 0 is 1. So actually I get 6 for y. So I get 6 for y and 2 for x. So this is 2, this is 6. And then lastly, I need to know what happens when I plug into 0 to both these. Oh, but I already did. So I need dy dt over dx dt. Dy dt we got was 3, dx dt was 10, so it's 0.3, or you can just write 10. 0.3, 2, 6, done. Now, I personally never ask students to write mx plus b anymore because I'm happy for them to just stop here. I was mean back in 2017, I guess, and I made them expand. 0.3x minus 0.6 plus 6, so y is equal to 0.3x plus 5.4. Success. Yep, I wrote it as 3/10 and 27/5. Find all times at which the curve has a vertical tangent line. So a vertical tangent line would be basically when the slope becomes infinite, when the slope is undefined. In order for that to happen, this is going to be 0. So the question's asking, when is x prime 0? X prime is t squared minus, so let's grab it. Oh, x squared minus 7 t squared minus 7t plus 10. We need to know when that's 0. I think it factors nicely into t minus 2, t minus 5 is 0, and you get these two possibilities, 2 and 5. The times, so it's just 2 and 5. Okay, so you can see that problem illustrated sort of everything. We had the vertical velocity, we had the horizontal velocity, we had the speed, we had the slope. And the only weird question maybe you could be asked is vertical tangent. So I tried to find a question on multiple exams that kind of had a little bit of everything. Okay, what do we got here? Here's another one. For both large for the low, consider the parametric curve defined by this. What does it say? It says the tangent line is vertical at the point B. Find the y-coordinate of the point B. And then it asks for a separate, maybe harder question. So you now know from what I was just saying that dy dx is dy dt over dx dt. We want to know when this is 0. That's these two spots. There'd be a spot here and a spot here. We'd have a vertical tangent line. You can get much more exotic things, so it's kind of fun. 3t squared equals 0. T squared is going to be 4/3. T is the plus or minus the square root of 4/3. They want the y-coordinate of this point. Let's see, I'd have to think about a little bit which one of these gives me a negative x, because that one's going to have a negative x, that one's going to have a positive x. Let's see, this is going to be 4. I would probably write this as 2 over the square root of 3, plus or minus, and then I would plug this in. If I couldn't tell, I might go to my calculator. Let's see, when I cube it, I'm going to get plus or minus 8 on top. That's 2 cubed. And I'm going to have 3 to the 3/2. So that's not that pretty. Minus 8 over the square root of 3. I see. So actually, it's maybe bad that I simplified that. How can I write these with a common denominator? I can multiply top and bottom by 3, so it is negative when I plug that in. Okay, I'm just going to check that I haven't made a grave error. Oh, this is a different problem. Oh, this is from a different test. Is it? Apologies. I have 2 computers now. It's quite exciting. So I don't have an excuse to not look at the solutions. Right. Oh, I only asked for the y-coordinate. That's why the problem's not as bad as I'm making it. That's why it's good for me to look at the solutions. It doesn't matter whether you put in the plus or minus here. That's how I was trying to make it so students didn't do what I was just trying to do when I wrote this. It's like I fell into the trap. Anyways, I didn't mean it as a trap. But it doesn't matter which one you plug in because you're going to be squaring. So you're going to get 2 the log of 4 over 3 plus 1 minus 1. Okay, that's fine. That goofy curve has one positive y-intercept which it crosses twice. Find the equation of the tangent line, the one that has a negative slope. So that sounds like a lot, but if you think about that point, that's when x is 0, sorry. So I need to figure out when x is 0. When is x 0? Well, it's going to be t cubed minus 4t equals 0, and so you can factor that and get 3 solutions. T could be 0 or it could be plus or minus 2. Now, actually the fact that I have some of these points, I think this was the negative one, this was the positive one, this is t is 0. I think we could have sort of figured out the motion. And so I think it's the positive 2, simply because I drew one of my arrows funny. Simply because this was the negative t, This is going to be when t is 0. This is going to be when you're at the positive version of that. So I think when you get here the second time, it's going to be at 2. But in -2 was when it was in the past. So I think I want you to plug in 2. But if you didn't know, you could try them both and see which one gives you the negative slope. So now I'm trying to do the equation of the tangent line there. Find the equation of the tangent line. So I need the slope. I need the x value. Now I know the x value is 0 at that point. The y value I can get by plugging in my 2. And at 2 and minus 2, it's going to be the same. So it's 2 log of 5 minus 1. And you might say, well, how would I have known not to plug in 0? Well, you could have and found out that it was negative, and that would have confirmed what I'm already saying. And plugging in the negative. So the only question is that m. What is that m? It's dy dt over dx dt. So dx dt already computed was 3t squared minus 4. dy dt is going to be 2 times 2t over t squared plus 1. You don't even have to simplify because you know you're going to plug in a 2 to that. So that's going to be 8, 2 times 2 times 2 over 5 all over, what is that going to be? 12 all over 8. Ooh. If you don't know how to simplify something like this, I often tell students, just figure out where your big bar is and multiply top and bottom by something that gets rid of one of your fractions. In this case, 5 does that. And so then you would see that it's 8 over 8 times 5, and you would see that it's 1/5. I found that that's safer than a lot of things I see students do. Now, the moment I did that, I'm now starting to doubt my labeling. I did not get a negative slope. What did I do wrong? It must be -2. So actually, I did do it wrong, but you can see how I caught my work. If I plug in a -2, the only thing that changes is that's negative, and this becomes -1/5. So I must have had my arrows drawn incorrectly. That was -2. Well, shoot, I should have plotted more points. But we found our way. Okay. Let's keep going. Do I have any other ones here? Maybe not. Maybe that's enough. Is it enough? Let's call it enough. Okay, so hopefully that's helpful, and then I'll move on to the next topic.